Assalamu alaikum warahmatullahi wabarakatuh. I'm going to talk about the first assignment of fluid mechanics. My name is Abdulrahman Saleh Ahmed and my matric number is 199632. To Dr. Nuruddin. Let's get started. Firstly, we have the liquid characteristics and how the liquid, what's the definition of liquid and the meaning of liquid. A liquid is a nearly incompressible fluid that conforms to the shape of its container but retains a nearly constant volume independent of pressure. As such, is it one of the four fundamental states of matter that other being solid, gas, and plasma, and the only state with the definition of volume but no fixed shape. That means there is no certain shape for the liquid. It only takes the shape of the container. The characteristic we have, assume that the shape of the part of the container which occupies the particles can move and slide past one another. And also we have the second thing, that not easily compressible. It's hard to compress it, the water, especially the liquids in general. Little free space between the particles. The meaning of little of that we have little space between the particles of each particle and the liquid. It's because of the solid, they are near to each other. Because of that, it's hard. It's able to compress it. Flows easily. Particle can move and slide past one another also, because the flow of the liquids is not as the solid. Solid is tight and strong, and gas flows easily also. And we have here the fundamental states and how we can change the state from solid to liquid, and liquid to gas, and gas to plasma. And plasma, it's rare to have it. The dimensional analysis. The concept of dimensional analysis, as we can see here from Dr. Rankman book, Engineering and Science. Dimensional analysis is the analysis of the relationships between different physical quantities by identifying their base quantities such as length, mass, time, and electrical charge, and units of the measure such as miles and kilometers or pounds or kilograms, and tracking this dimensional as calculating or compressings are performed. The conversion of units from one dimensional unit to another is often somewhat complex. Dimensional analysis, or more especially the factor label method, also known as the unit factor method, is widely used technique. This is the common technique that we have in dimensional analysis for such conversions using the rules of algebra. Then we are using in dimensional analysis a lot of algebra in mathematics. And here, as we can show from the figure here, what's the quantity and the samples and the meaning, and here in dimensions, each sample, what does it mean? And the application of dimensional analysis, as we can see here, is the development of an equation for fluid phenomenon. That means that we can develop an equation by using dimensional analysis. Conversion of one system units to another unit. As we can take it as a conversion factor from units to units, and reducing the number of variables required as an experimentally program. We can use the programs, the experiment, to reducing the number of variables. Develop principle of hydraulics simulated for model study. Next we have the types. We have two types here. Regulus, Regulus, here Rayleigh's method and Buckingham's pi theorem. This is the two types of the dimensional analysis that we are using right now. Firstly, we have the Rayleigh's method. It's a basic method to dimensional analysis method, can be simplified to yield dimensionless groups. Controlling the phenomenon, flow chart below shows the productions there. As we can see from the graph here, it's shown that indicates the functional relationships in the form, at this form actually. And second step, that determine the net power of each of the three dimensions, and also apply the principle of dimensional homogeneity and solve the simulations equations by using the C is the dimensional constant and the xn is the independent variables. And here we have the application, a real fluid mechanics application on Rayleigh's method. Considering the problem, this is the question, that considering the problem of containing the drag force on a body moving through a fluid, that's D and by and drag force, especially specific mass of the fluid dynamic velocity of the fluid body of reference length and body velocity respectively. Then this is the way how we're gonna solve it, but we have the equations here and how we apply these equations to the application itself to solve the problem here. And we have the step 1 and we have here the second step. By the exponent we obtain like F and L and T, and also for the second step we take the 4 unknowns and we apply it on the equation itself, as we can show here. And also now we're gonna go to the second part, is Buckingham's pi method. It's a more generalized method of dimension analysis developed by E. Buckingham and others, and it's the most popular now. This is arrange the variables into a lesser number of dimensions group of variables. Because of the Buckingham used the pi to represent the product of the variables in each group. We can call this method of the Buckingham pi theorem. If n is the total number of variables in a dimensional homogeneous equation contains m and fundamentally dimensions, they may be grouped into n and m pi terms. And we have here the steps and how we're gonna do it, like the f and how many unknown variables we have. Also here we have the procedures, like we have here 6 procedures. List the variables and compute the numbers and write the equation and write the general form and select the repeating variables, and also solve each pi term for the unknown exponents by dimensional homogeneity. Also here, Buckingham pi theorem, this is the real application example from fluid mechanics. And here the example is saying that we have 4 steps to solve this application. And the example considering the problem and drag the force of body moving through a fluid, and also same question, but this is the second, but we solve it by the second way and by the Buckingham pi theorem way method. And I think that's all for today, and thank you for your watching.